relative motion ना. See, motion is actually always relative. Okay, it's like you are walking on the road. So every time you have so many frame of reference, right? Like if I am walking now, you are my frame of reference, these walls are my frame of reference, these boards are my frame of reference, so many things. Let's say if you are in space, then let's say in space, blank space, dark space. Can you define your motion? What is the condition there in the space to define if you are in motion or not? Yeah, but how you know? Let's say there is just you only. In blank space, there is you only. How you define that you are in motion?
Distance between me
And there's nothing. Can you say? No. You don't know whether you are in motion or not. Okay? Now let's say there's two things. You, okay? Vision, right?
Yes, sir.
And let's say it's me. You guys. Not on the board. We both are in the space. Okay? Now, me and you are in space. Can we define that we are in motion or not?
Yes, sir.
How?
Distance increases or decreases.
Yeah. So, we will see that with the distance between me and you or me and anybody in the space is changing or not, right? With time, is that distance changing? Whether it's increasing or whether it's decreasing, right? So, motion is always relative. If you do not have any other person other than you, okay, then you don't even know whether you are in motion. Yeah, of course, it's not necessary to be a person.
Object.
Let's say this is object, right? Let's say this is the moon. Okay? This means that moon is the observer or you are the observer, right? So you see the moon and you observe that distance between you and moon is, let's say, changing. Let's say it's decreasing. So what will you say?
And the moon does.
Yeah, you can say that maybe you are going towards the moon or moon is coming towards you, or maybe both of you are coming towards each other. Get it? Right? It means that this can increase or this can decrease. Right? Distance can increase or distance can decrease. Right? So, for motion, you always have to have at least two frame of reference. Always. Okay? At least two frame of reference. But you know, one frame of reference we say observer, other frame of reference we say observant. Like you are observing, so you are observer. Okay? Other frame of reference we say observant. Our choice. I can be observer, then you are observant. I am observing you. If you are observing me, then you are observer. I become observant, right? Okay? So this is how motion works, right? Observer or observant, but at least two. Get it? At least two. So for the motion, first thing, of course, linear motion. We are talking about linear motion now, okay? Not the angular motion. Alright? Linear motion. Okay. So first thing that you have to do to check the motion. To check the motion between any two body, okay? First thing you have to do is you have to check the rate of change of distance between them. Okay? Rate of change of distance. Okay? If of course they are moving straight towards each other, distance becomes displacement, same thing. Alright? How this distance is changing? So you have to first check the rate of change of by which rate distance between two bodies is decreasing or increasing. This is what you have to first check. Now there is two things, no? Observer and observant, right? So whoever is the observer, observer see himself at rest because see I am observer, I am in the space, there are other body in the space, right? If I see myself only, Can we see that whether we are moving or not? No. So observer observes other and don't check their motion. This is the nature of the observer. Okay? So if there is an observer, he will see only the observant, not himself. So observer thinks himself always at rest all the time. Okay? Observer takes himself as one at rest. So it's always at rest. Observer thinks himself as rest all the time. Okay? And observes the observant. Okay? Observer observes the observant. Okay? It observes other. Okay? So if I will say that distance between me and you is changing with 3 meters per second, I am the observer. I am the observer. Then who is moving? You are moving, right? With what rate? Good. If in between us, okay, you are observer. You are observer. Distance between us is moving with 10 meters per second. Then who is moving? I am moving now. Who is observer? Because you are observer, right? So see, motion is same between us, right? Motion is same. We don't know who is moving. Motion is same. If I am observer, then I will say you are moving. If you are observer, then you will say I am moving. Okay, got it now? That's the nature of the observer. If you want to copy, you can copy. Okay. So see, motion that we are learning, motion what we are learning should work everywhere, right? Because anyway we are learning motion, right? You should work on the earth. The same motion should work out to the earth, in space, on the planets, near to the stars, near to the black holes, anywhere, right? Motion should work the same way. So this is how you have to learn motion in such a way that it should work no matter where you are. Not like just on earth you are running, you can see everything, so you can see what your speed. Just think, if you have to send the rocket to the Mars, how do you send it? Here you know, here I will say, here if I will say, go your home, you can go your home, right? Easily. Why? Because you have so many frame of reference here. So many frame of reference you can observe. Okay? According to that, you can navigate to your home. But if I will say, you have to go to Mars, how will you know what is your speed? Isn't it? Here you know, because you have this blackboard. I have this blackboard. I will run, I will observe the blackboard, and I will say what is my displacement in the given time. So I can observe so many observers, so many events here, right? But you are going Mars, you have to reach Mars in some particular time. How will you know what is your speed? Because you can't observe the Earth from everywhere. Isn't it? You are going to Mars. Can you look at back and observe the Earth? And then you have to check your motion from the Earth? No. Here we have the roads, trees, everything, right? Space is not like this. But we are sending rockets on the Mars. You know Voyager? Voyager was a satellite, okay? Actually not a satellite, but like you can say like a spacecraft, okay, something like that. We send that in the space only. It is just going, still is going. How do we calculate their motion? Because their motion with respect to Earth can be something different with the Mars, with the moons. So many observers are there, right? So if you learn motion very well, you can calculate your motion wherever you are. Wherever, whether you are going on the Mars, whether you are going to the Sun, anywhere. Okay? Okay, now easy things. Alright. I will give the rate only first between them, okay? The rate of change of distance in this case, because they are moving on the linearly, okay? They are moving on the same axis. So rate of change of distance between them, let's say A and B, is 10 meters per second. Okay? A and B, 10 meters per Now I did not say whether they are moving towards each other or going away from each other. Okay? So if I will say, what is the speed of B? If I say what is speed or velocity of B? A is the observer. See, you have to become observer. Okay, those only questions. You have to become observer. Then you can see it correctly. So now you become observer. Means you become A. And I will ask, or you have to calculate what is the motion between you and B. You tell me what is the motion between you and B. This is you, V Z. This is B, Burgess. Okay. So the rate of change of distance between them is 10 meters per second. Now you have to tell me what is the motion of B.
Towards the
Yeah. Here this question comes now. Rate we have, right? Now you have to say it's coming towards you or away from you now, right? Let's say if I show this arrow. Now you understand. So now tell me what is the motion of B?
opposite direction of
Yeah. 10 meters per second
opposite line.
in x-axis. Okay. This arrow shows positive x-axis. Okay. So B is going in positive x-axis. Okay. With the rate of 10 per second. You can say right. Now you see same B. Okay. Same person. B. Alright. B is here. B is here. This is the arrow. Who is observer? You observer. Rate of change of distance between them is still 10. Okay? The rate of change of distance between them is 10. Now you tell me what is the motion of B? Same, na? 10 meters per second. In which direction? X-axis only, right? So you do not have to mug up that when it will go away from you, you have to sum it or add it. When it will coming towards you, you have to subtract it or add it. No, you do not need to mug up it. Mostly we do like V2 as V1, V1 as V2. No, okay? Don't do like this. So B, see, you have to check one thing: rate of change of distance between that two, and then who is observer. If you are the observer, you are not moving, he is only moving, right? And then you just have to check the direction. Simple. In which direction is moving? X-axis. Simple, na? So velocity of B, right? With respect to U, na? Vz, right? Is what? 10 meters per second, right? When bridges were here, and moving into this direction, what was its velocity with respect to Vz? Same thing, na? That is 10 meters per second. Got it? So this thing is very important. The rate of change of distance or actually displacement also. Okay. The rate of change of displacement or distance between them, because it's linear motion here. Okay. And then who is observer? First is rate of change of distance. Other is who is observer. And then third is the direction. Okay. Easy now. One more thing. Wait. One more. Vz versus. Okay. I will give the rate only first. Now let's say rate is 2 meters per second. Rate of change of distance or displacement between them is 2 meters per second. Now let's say you are observer, V is observer. Can you tell me what is the velocity of B in this case? Velocity of B. That is not given, na? How you decide? You don't know, na? Yeah.
Observation rest, no, sir.
Yeah, he is at rest.
Okay.
And rate of change of distance between them is. But do you know he is going away or coming towards you? No. So can you say exactly? You know the rate. Can you say the velocity? No, because you don't know the direction, right? So if I give you the direction, now you tell me what is the velocity of B? Minus 2 meters. Right now, so velocity of B with respect to V is equal to minus 2 meters per second. Is it right? Same thing. If these bridges come here, Okay, and moving into this direction. Okay, rate is same. Rate is same. 2 meter per second. Now tell me, what is the motion of these bridges with respect to you? That is Vijay. Minus. Yeah. So every time we are doing the same thing. We are finding the rate of change of distance. Then with the observer, and then in which direction they are moving, right? They are moving in negative direction. Doesn't matter. It's coming towards you, going away from you. Doesn't matter, right? What matters is direction only. Got it? Or no? Okay. Okay. So. See, if I will not mention the frame of reference, if I will give this velocity, if I will not mention the frame of reference, then frame of reference will be ground. Okay? It will be ground. Okay, ground like something that cannot move. Let's say top. Okay? So bridges, Vijay and bridges. Alright? This is moving with 2 meter per second. It means it's moving with 2 meter per second from the top or ground, you can say, right? This is moving with 4 meter, let's say 3 meter per second. Okay? 2 meter per second, 3 meter per second. So, what we have to find first, tell me what is the motion of Vijay with respect to ground?
Plus 2 meter per second. Plus 2 meter per second.
Yeah. What is the motion of bridges with respect to ground?
Plus 3 meter.
3 meter per second, right? Good. Okay. It means that the rate of change of distance between Vijay and the tower is 2. Or you use plus 2, right? Rate of change of distance between the bridges and the tower is 3, right? Now tell me, what is the rate of change of distance between Vijay and the bridges?
Minus 3 minus 2.
Rate of change of distance I said already, not the direction, just the distance. Okay? So what is the rate of change of, see, you are coming 2 meter in 1 second. He is coming 3 meter in 1 second. So what is the difference of the rate? 1, right? So in this case, the rate of change of distance between them is 1, right? Now, if Vijay becomes observer, you become observer. First thing that we decide who is observer, right? Second thing, rate of change of distance. Third thing, direction. So, rate of change of distance between them is 1, right? Now, if you become observer, then what is the speed of V?
Plus 5.
Follow the method. Observer, you, rate of change of distance between them is 1,
Okay.
right? In which direction?
Opposite direction.
Plus, right? So, this person, you, right, is the observer now. It means you are at rest, you are not moving. Now you are observing this motion. What is the rate of change of distance between you and the B? Is 1, right? Now in which direction?
Positive.
In this direction, right? Why? Because see, he is moving 1 greater than you, right? Bridges is moving 1 magnitude greater than Vijay. Okay? So that's why Bridges is moving into this direction with 1, right? So rate of change of distance between them is 1 meter per second. Observer is Vijay, right? So velocity of B with respect to Vijay equal to, first thing is that magnitude will be the same, huh? Second is direction, right? Who is going faster? He is going faster. Get it? So 1 meter per second. Got it? Okay, doing same thing. What is the velocity of Vijay with respect to Bridges? Minus? Yeah. Why? See. Now Bridges becomes observer, right? He was moving with 3, with the ground. He was moving the 2 with the ground. So they were separating, because he is moving faster, he is moving slower in the same direction. So they were separating, right? They are separating. And me and you stands here. If we are separating, if I become observer and we are separating, I will say that you are going away from me, right? Now you are here, right? And you see that we are separating. You are here, I am there, let's say. Or let's say you are there, I am here. And we are saying that we are separating. We are separating, right? But I say that I am not moving. So who is moving? You are moving. I am separating. It means you are going away. Get it? You are here, let's say you are here. Okay? I am here. And we are separating. It means you are going away. Rate, you know? Rate is what? 1. Now you are going away from me, right? So in which direction will go? This direction only. Get it? So minus 1. Is it right? Yeah. Minus 1, no? Wait. Okay. This is Vijay. Okay? Top. And one more thing you understood now, it doesn't matter. This person is here or this person is here. Doesn't matter now. We saw that, right? It doesn't matter. The axis matter only. Right? So, with the person right side of the tower or the left side of the tower, doesn't matter. Okay? Let's say this one moving into this direction with the 4. Okay? Meter per second. If the observer is not here, then it's a ground, right? This is moving with, let's say, this direction. 3 meters per second. Okay? So what is the velocity of bridges with respect to ground? Bridges, okay, bridges, yeah. 3 meters per second. What is the velocity of Vijay with the ground? Yeah, we use a minus, right? Because y is negative axis, right? Okay. So what is the rate of change of distance between Vijay and the bridges? See, you can observe this like this. Vijay, okay, is going away from bridges. Bridges is also going away from the Vijay, right? I stand here, you stand there. I move this direction, you move that direction. What will happen? You are also trying to go away from me. I am also trying to go away from you only, right? So both of our velocity is responsible to increase the distance between us, right? Get it? So what is the rate of change of distance between them? 7, right? 7 meter per second, right? Now let's say observer is Vijay. V is observer. Okay? What we understood that they are separating. What we understood is that they are separating. First thing, right? Now Bridges is observer. Bridges is observer. Sorry, Vijay is observer. So Vijay is not moving, right? So Vijay will observe Bridges, right? So with what rate Bridges is moving? This is the rate of change of distance. I say with respect to Vijay. Okay? So what is the rate of change of, sorry, what is the velocity of Bridges with respect to Vijay? So velocity of Bridges with respect to Vijay. Rate is 7 and moving this direction, right? Separating this because now I am observer. Vijay is observer. So what Vijay see? That we are separating. How we are separating? This is going to this direction, right? It means plus 7, right? Right? Now if this become observer, if B become observer, this Bridges become observer. Same, rate is same. This become observer. They are separating. How they will separate? If this will move, right? Right? Now he will not move. He will move, right? With what? This rate in which direction? This direction. Right now? So velocity of Vijay with respect to Bridges is minus 7. Is it enough? Right? Copy.
So this case is both in one direction, this case is both in opposite direction.
Yeah. So no matter any directions I will give, you can solve it, you will see. Okay? Doesn't matter what is the directions. here B is moving with 4 meter per second, right? With respect to ground. If I say C is going with 2 meter per second with respect to B, right? This is C, right? C is moving with 2 meter per second with respect to B. It means who is observer? B. So what is the rate of change of distance between B and C? I suggest rate of change of. When I say speed or velocity, then you will say the axis. Okay? So C is going with 2 meter per second with respect to B. It means that this sentence means that rate of change of distance between B and C is 2. Now this arrow shows that C is moving. If B becomes observer, then what BC, because with respect to B, right? B becomes observer, right? Then B see that C is moving, arrow shows the direction, right? C is moving with 2 meter per second into this direction, right? So B itself is moving with 4. Then what should be the velocity of C? No, C again. No, wait. First tell me what is the rate of change of distance between B and C? 2 meter per second, right? Let's say rate of change of distance between me and you. You are here, I am here, okay? Rate of change of distance between me and you is 2. If you are going with 6, then what should be my speed? 4. Right? Get it? If you are going with 6 speed, I should have run with 4. Then only you are going 2 ahead of me, right? This direction is the same thing, no? This is the direction, right? So C is moving 2 meter per second with respect to B. B is observer. So C is moving in this direction with respect to B only. So what should be the motion of B? Motion of B is already given 4. Then what should the 4 is the with respect to ground, right? So what should be the motion of C so that motion of C with respect to B becomes 2? It means C is moving with 2 meter per second greater speed. Then it's possible, right? Get it? So what is the velocity of C with respect to ground? 6. Right? This is going with 4. So this has to go with 6. Isn't it? Then only BC then he is going with 2. Right? 2 meter, 6 meter per second. This is with respect to ground, right? So the velocity of C with respect to ground is 6 meter per second. Where do we get these kinds of questions? Where there are so many frame of reference. What you have to do is that you have to first calculate motion of all this body with respect to one frame. With respect to one frame. Better you take that frame as the ground. Better you take that frame as a ground. Okay? What we did here is that we did 4 plus 2. Okay? No need to mug up. What no need to mug up. Okay? It all comes from the observation only. If you mug up, sometimes you make mistakes in writing sign. Definitely. The first thing you have to learn that C is 2 meter per second with respect to B. It means rate of change of C and B is 2. Right? Direction is given. Direction is given, right? B is here, C is here, direction is given. They are separating. How can they separate? He is moving with the 4. What should have to move? 6. Right? Isn't it? He is moving with the 4. He have to move with the 6. There will be the rate of separation will be 2. Right now? So we got its velocity with respect to ground, right? We have this velocity with respect to ground already, right? Velocity of B is already given, huh? 4 meter per second, right? What is the velocity of A with respect to ground? So C we got, right? With respect to ground, C we got now. Okay? So first thing, what is the rate of change of A and B? Means rate of change of distance between A and B. A and C, sorry. A and C, yeah. So what is the rate of change of distance between A and C?
C is the observer.
Yeah, C observer. So rate is given now. Right? A is moving with 2 meter per second with respect to C. It means that this sentence means that rate of change of distance between A and C is 2. Okay? Now you have to check in which direction. Who is observer? Observer is who?
C.
C is observer. Direction is this direction, right? This direction is the like positive directions. Okay. So if this body is moving into this direction with 2 meters per second with respect to C, right? Then it means that it will reach, right? Because this motion is positive, right? Isn't it? This means that this will reach one time at C and then will pass also C. Isn't it? So what can be the motion of A? What is motion of C? 6. So what can be the motion of A? If 4, then they will separate now. Just think, let's say A is going with 4. Then motion of and C is 6. So this arrow will be like this now because they will separate. Got it? You observe everything. Okay? I showed arrow like this. So see A is moving with 2 meters per second. In which direction? In positive direction. With respect to C. A is approaching C. A is approaching C. How is possible? A have to move faster than C. Isn't it? A is approaching C with the rate of 2. How is possible? If A have to move faster than C. Right? And how fast? It's given 2 meters per second fast. Right? So C is moving with 6. A have to move with 8. Okay? Once you observe these things now, you do not need to write anything on the paper. Okay? Lastly, you will see what's his name? One of your student in your batch. Okay. Watson. Yeah, you'll see. He don't use pen and paper. When these kinds of questions come, he don't use pen and paper. He just see these everything in the brain, calculate everything, same instantly. Once you will know what is written, what does it mean, what this sentence says. Once you know these things, you do not need to write pen and paper also. Okay, you can just only say this. Motion between A and C is 2. A is motion positive. How it is positive? You have to move faster than C. Get it? So what is the velocity of A? What is the velocity of A? 8 meters per second. Right? Good. So now we have velocity of all the person with respect to ground. Right? So if I will say, what is velocity of B with respect to A? So with respect to A, right? So who is observer? A is observer, right? So with the ground, everyone is given, and all the velocity is given with respect to ground, right? So B with respect to A with the ground is A with the ground is 8, B with the ground is 4. Who is observer? A is observer, right? So what is the velocity of B? Yeah? Yes, it's working. Think it like real life. A is going with 8, B is going with 4. Who is going faster? A. So it's a separating or it's a closing? Closing or separating?
Closing after the separating.
Yeah. So direction is same, huh? Doesn't matter closing. You stand here. First I will close, then we will separate. Direction is same still. Get it? Yeah. So what is the velocity of B with respect to A? B with respect to A. Yes. How much? Minus 4 meters per second. I become A. You come here. Yes, you come here. Okay. You there? Okay. Now I become A. You are going with 4 only. You are observer, right? I'm observer. Okay. I'm observer. So I'm going with A. Okay. You are going with 4 only. So what will happen? Separation will happen, huh? With what rate? 4 rate, right? First thing is that separation will happen between us, right? With what rate? 4 rate now. Now if I say I don't move because I'm observer, then how will we separate? If he will go away from me. Is it right? Isn't it? So I become observer and separation rate is what? 4. Then you are moving away from me.
Yes.
From my perspective, right? Because what I see is that I'm not moving. But fundamental thing is that distance is increasing, right? With what rate? 4 rate. So you are going away from me. I'm the observer, right? So it's a minus 5. So according to me, your motion is minus 4. Okay? So it's a minus 4 meter per second. Right? Depends upon who is observer. Get it? Okay? So if observer is A, sorry B, okay? With respect to B. Observer is B now. Now tell me.
4 meters. Yes, 4 meters.
Yes, 4 meter per second, right? Same motion. Rate of change of distance is same. Now observer is at rest, and this one is moving, right? This one is moving with the rate 8. Separating, right? 8 the 4 na? Because this was moving with the 4, right? In this direction, this was moving with the 8. So rate between them is 4 only na? And separation is happening into this direction, right? So it's positive, right? 4 meter per second. Is it okay? Okay? Alright, okay. Okay. So we will write some point. Write some point. Whenever more than 2 frames of reference are given, whenever more than 2 frames of reference are given, whenever more than 2 frames of reference are given, better find first velocity of all the object velocity of all the object with respect to one frame. Okay, velocity of all the object with respect to one frame, that is ground frame. Better is ground. Okay, so that is ground frame. All right. After this, okay, after this, find the rate of change of distance between. Find the rate of change of distance, or you can also say displacement. Okay, linear rate of change of distance or displacement between 2 frames. Okay, I did not mention velocity. Okay, what I mentioned is the rate of change of distance. I don't want to say about direction now, right? So you have to check that with what rate distance between the 2 observer is changing. No matter how many observers are there, right? There can be another combination. Let's say there are 3 bodies. So how many combinations? If there is 3 bodies, this with respect to this, right? This with respect to this, and this with respect to this. So 3 combinations, right? So what you have to do? You have to first find the velocity, or the, you can say, rate. You have to find the rate of change of distance between the body, right? First thing that find the speed or velocity with respect to ground of all the frame. Second is that find the rate of change of distance between 2 frames, all the combination of the 2 frames, right? And third is that check that motion direction. Check the directions. Third is check the directions according to who is observer, right? Check the direction. Check the direction according to who is the observer. Check the direction according to who is the observer. Okay. All right. So let's do one more question. right side, left side, does it matter? No, doesn't matter. No? We have checked, right? Even this person is here, same velocity will happen. Okay? Doesn't matter this person is left side of the person or the right side of the person. Doesn't matter this is right side of the tower or the left side of the tower. Doesn't matter, right? Okay? A, B, C. Doesn't matter up or down. Okay? Doesn't matter left side, right side, up side, down side, doesn't matter. Okay? The axis of motion only matters. Axis of motion only matters. Okay? Let's say 2 meters per second. Arrow is important thing. Alright? Here I show this arrow. It means that this is moving with the ground in positive axis, right? Okay, now? So arrow doesn't matter, right? Otherwise they will mention it that going in x-axis. Okay? I am showing arrow, I can't write all the time going in x-axis. Okay? See, if you understand the concept, it looks complicated. But if you understand the fundamentals, you can find everything very easily. What is the step? First, there are so many observers, no? So many observers, so many bodies are moving, right? Isn't it? First thing you have to calculate is that motion of all the body with respect to ground. Okay? You can start from anywhere. You can start from, doesn't matter, you have to start from A only. You can start from anywhere. So A already given the ground. Okay? So for the A, what we can write? V of A equal to minus 6. Minus 6, huh? Because going left, right? Minus 6 meter per second, right? Velocity of B is also with the ground as I given us. Yeah. Okay? Easy. Velocity of B is what? 2 meter per second, right? What is velocity of C? In C, the rate of change of distance between C and A is 2. Huh? In C, rate of change of distance between C and A is 2. Right? So, C is moving right side of A. Get it? A is observer. C is moving right side of A. A is observer. And A is moving with 6. Then what should be the velocity of C? Very good. I am impressed. Minus 4, huh? Actually minus 4, right? Minus 4, right? So A is moving with minus 6. A is moving with minus 6. C have to move with minus 4, right? So A will observe that C is moving with 2 in this direction because A is moving faster and going left. Get it? Very good. So it's a minus 4 meter per second. Okay? What is velocity of D? So D with respect to B is given now. So rate of change of distance between D and B is 4. In which direction? Plus that direction, right? Plus that direction. So B is 2. Rate of change of distance between them is 4. And C plus direction. He is going with plus. And he is going with 4 ahead, right? So what is the motion of D with the ground? 6. Then only this will move in plus now. Right? 6, right? 6 meter per second. Get it? D is moving with 6. B is moving with 2. Observer is B. We will see that D is going with 4 into this direction. Get it? Okay. So now we found in all framer, not in all framer, all body with the ground floor, right? So find velocity of A with respect to B, velocity of B with respect to C, velocity of D with respect 2 d. This is the A instead of C with respect to B. Yeah. Tell me. With the ground it's given.
So velocity of A with respect to B is minus 8 meter per second.
A with B. Okay.
Opposite direction minus 8.
Yeah. Wait. So B is going with the 2 plus. A is going with the minus 6 minus. Minus 6 means minus, right? So with respect to B becomes observer. Right? What is the rate of change of distance between A and B?
8 meters per
Yeah. And which observer?
second.
B. So what is the answer?
Minus 8 meters.
Minus?
8 meters.
Very good. Minus
8
8 meter. Okay. Very good. Next. B with respect to C. So what we are doing? First checking the rate. No? So B with the C. B is 2. C is 4. B is 2 plus C is 4 plus. So what is separation rate? 2. Now, this will be 2, which means 4 separation rate is 2. Okay? Who is observer? C. C becomes observer. So what is the velocity of B? Yeah. Because now C1 going faster, but he thinks he is at rest. Isn't it? He thinks that he is at rest. It means, okay, it was minus 4 now. It was minus 1, right? So the rate of separation is 6 actually, right? Yeah. Rate of separation, this is minus 1 and not 4. Okay? So rate of separation between B and C is 6. Who is observer? C is observer, right? So what C is C?
6 meters.
Yeah, plus 6. Very good. Equal to 6 meters per second. Very good. Now D with A. D we have found. Yeah. D is 6. A is minus 6. What is separation rate?
12 meters.
Yeah. 12 is the separation rate, na? Who is observer? A is observer. So,
Yes, sir.
very good. C with B. Where is C? Minus 4. Where is B? 2. Separation rate is 6. B is the observer. B is the observer. So minus? Nice. Excellent. Okay. Is there any other complication possible? No other complication possible. This is complex itself. Okay. What can we do? We can add one more frame, two more frame, but we will do the same thing now. We are just increasing the numbers. This is the maximum possible. Okay. Now we can just increase the number of domains only. It doesn't make any change here. Okay. We will do the same thing only. We keep writing. Only this. Okay. Very good. If you solve this question, now you can solve all kinds of questions of relative motion. At least linear relative motion. Okay. Copy this. Okay. Same question, little different. Okay. I just want to see how you use the vectors. Okay. Find the velocity of A with respect to ground, if not given already it's not given, okay. Velocity of B. See, this is 6 meter per second means with respect to ground at an angle of 60 degree. So you can break this into in x and y.
3 meters per second.
Yeah, in x, huh? In y, cos. Cos this and sin 60 degree. Break 3 by 2. Okay? 6 into 3 by 2. Okay. and then of course with respect, if not given, then with respect to ground, okay. Then position of A with respect to already B is given, okay. Let's say B with respect to A, okay. Tell me.
So here V velocity of B is 3 meters per second. Cos theta.
Velocity of B, yeah.
Velocity
So
of
B in X, velocity of B in X, huh? Is what? 6 cos 30. Sorry, 60, na? That is 6 cos 60 means 3 meter per second. Of course, with respect to ground, right? Velocity of A with respect to B is given.
Here B is 6 meters per second or 3 meters per second, sir?
B is 3.
No, sir. With respect to A is velocity 8 meters per second.
See, A is moving with 8 meter per second with respect to B. So A is moving with X now.
Yes, sir.
X, we can compare X only with X. Okay? We have to compare X only with X. If we are talking about X, okay? Forget about Y. Deal only with X. Just keep one thing. This is the Newton's law. Okay? Keep this thing in your brain. If there is any vector, any force, velocity, acceleration, whatever you are comparing, okay? When you are comparing the things into x-axis, you do not even have to check y and z, because x-axis doesn't even interact with y. I am saying x-axis, not at any angle. Okay? Like this is at any angle, not purely in x. No? When something is pure x, they doesn't care about the y and z. They simply doesn't interact. Okay? So what is in x? 8 meter per second, right? Arrow is shown, right? Means going negative axis. Okay? With respect to B. What is B? 3 meter per second. Okay?
Sorry.
Rate of change,
no, sir. Rate of change of distance between A and B is 7 meters.
7.
11 meters.
No, how? Yes. See, separation is happening. This arrow shows that this arrow is not with respect to ground. This arrow is with respect to B, na? Okay? This arrow is not with respect to ground, but with respect to B. Okay? So, rate of change of distance between A and B is 8. Actually minus, because of the direction, right? Between A and B, if B is going with 3 into this direction, what have to A move? Yeah. Yeah, ground. This A have to move with what? So that separation rate will be 8. Yeah. Minus 5 na? Because of the direction is given, right? Because direction is given. Okay? Let's see. If this is going with 3, if this A will move with the 5 into this direction, will separation happen with the rate of 8? No, no. Right? So this arrow have to go into this direction, right? Into this direction with 5. Now, so what is the velocity of A with respect to ground? Just confirm minus 5. Yeah. So A with the ground we are finding now. Minus 5. Right? Got it? B with the ground is already found, right? Okay.
B.
So what we have B with respect to A. Already given, not given, alter just it. Right? If A with respect to B is 8. Okay? Actually minus it. Minus it, right? So B with respect to A is just opposite of that. Or you can find B with respect to A. What is the rate between them? This is the rate, na? Rate is given, na? This is the rate. Okay? Or if you have with the ground, right? You have with the ground. So what is the rate of change of distance between them? 8, right? Who is observer? A is observer, right? A is observer. So A is at rest. So in which direction this have to move? In this direction A is observer, na? Yeah. Okay. In which direction this have to move? In which?
Positive x.
Yeah, this become observer na. Okay. Positive x, right? With the rate of 8. Okay. So 8 meter per second, right? Because A is observer. Okay. Got it now? So if they give in the vectors, just break them. Okay. And then compare x with x only. If y is given, then compare y with y. Okay. Don't compare x with the y. Alright. Okay, if I say here we are getting the relative velocity in particular axis, right? All these are in the x axis, na? All these velocities are in x axis. You can see here, find in x. Okay. So now I will say find the velocity. Okay. If I say find the velocity, okay, of b with respect to a. B with respect to A. Here say velocity, find the velocity of B with respect to A. We have already found B with respect to A, but this is in x. This is x. All this we found in x now. So velocity of B with respect to A in x is 8 meter per second, right? 8 meter per second. So in x we have, right? B in x we have with respect to, of course, with respect to A, right? B with respect to A. Okay, B with respect to A is what? 8 meter per second. So this is in x, right? So you can write here I cap. Now velocity of B with respect to A in y. Velocity of B with respect to A in y. Yeah. So who is observer? A is observer. A is observer. He is moving into the direction. So 6 sine 60. Simple. Okay. Observer is this one. He doesn't have any motion in y. So simple. This with respect to, sorry, this with respect to this, right? Is simple 6 sine 60. Okay. Which is 6 sine 60. So we will write this plus this. Get it? Like this plus this vector form, because we have to find the velocity of B with respect to A. So add them, na, vector form I cap j cap, right? This becomes I cap, this becomes j cap. Add both of them, right? Okay. Simple, na? Yeah. Okay. Very good. Copy.